Okay, welcome to the 13th class of Big Data Analytics. We actually, near the end of the class, in fact, in terms of teaching, this would be pretty much the final lecture-like class. The other two classes will be project presentation. Of course, following each presentation, I would make some comments, some hopefully constructive comments, so you can learn from those comments, and that will be the next two classes, and that will take us to the final. Okay, so we have 2 weeks. Originally, I was planning for just one session of project presentation, but that's kind of based on a group project. Since we have individual project and we have about 40 students, we discussed with the TA, and it's probably not enough. Okay, so I guess what we've been doing. A lot of you probably, like when I was in my undergraduate years, just went to class without really reading the syllabus and whatnot, but it's worth going over that the syllabus that I prepare. So basically, what I wanted for this course is not to make you a data scientist. In a sense, it's not possible to do that in one course, but I wanted to put you sort of like in the mind of what a professional data scientist does. Okay, so it's sort of like. What does a professional data scientist do? Look at the problem, look at the data, assess how good the data set is, assess how good one's own understanding of machine learning or statistical method is, and try to formulate the problem and turn data, raw data, into insights and analytics. So that's really objective number one. Okay, and of course, objective number two, which is as important, if not more so, is to understand the underlying concept, the mathematical, the statistical computation foundation. Okay, so a lot of time, even though if you were to watch, say, like a how-to video on a tutorial, you can say, okay, well, first you turn on a Python notebook, and you download this library, and then you format this data this and that way, and then you run this. So there's a lot of how-to tutorial out there, and they are very good, they're very useful, and I want you to use that. I'm not saying don't use them. Use them. Rely on them for tutorial. But what tutorials don't give you is understanding why is it we're doing certain thing. Why do we do principal component before we feed it to a neural network? Sometimes we don't, sometimes we do. Why do we scale? Why do we, these are the understanding that I want you to have. So you don't become a very superficial user of data analytics tools, okay? So and of course you have to experience with some coding. Okay, with some coding. Now again, if for I think a quarter of you, maybe a little bit more than a quarter, maybe a third of you, or maybe even nearly a half of you, who are going to be going on to data applied digital intelligence, you will need to learn other languages to be able to do coding that is ubiquitous. In other words, the sort of coding base that is used by big organizations, small research group, GitHub code repository. So that would mean something like a more low-level language like Python. It's not low level. It's more like a general purpose language. It sort of does everything. Okay. Whereas the rest of you, maybe a little bit over half, who are not necessarily going to be able to do the heavy duty programming yourselves, because you're going into sustainability, you're going to healthcare, you're going into smart cities, you would be better off with a very high level platform. So Mathematica is one of those very high level platform. It's sort of like, it's functional programming, you can tell it what to do, but it's also decorative, very high level decorative language in the sense that you tell it what you would like done. I want to build a machine learning model from this input to that output. And I would like to test the performance. Okay, so you sort of declarative, you declare what you want to do. You don't really tell the computer exactly the steps. You know, under the hood, there's a lot of clever coding that turns your intention into actual codes. Okay, so that's and also, you know, if you don't learn Mathematica here, chances are you won't be able to, because it's a very expensive software. It's not something that you know, well, you could, but you know, I would imagine most of you probably would not want to do that. So within a university setting, it's a perfect setup for it, because you know, the university spends, you know, 500,000 ish, but whatever a year to hire the code for the students. Okay, so it's a high level. The other thing is it's also very visual, and it allows you to do all the prototyping and all that. And the bonus is that if you are really smart, some of you are, you know, pretty much into deep diving. Even if you're going into applied digital intelligence, and you will be learning Python because you can communicate with the rest of the programming community, there's a lot of capability that Mathematica has, analytical capability that you won't find in Python library. And so you can have access to that. So those are really cream of the crop, you know, people who are really true nerds. They can really appreciate the functional capabilities over and above, say, Python code base. Okay, and finally, of course, you know, this is a little bit of an element that I didn't get to implement very much in this class. Okay, I have to say that this objective 4 probably was not really achieved in this class, because the way I designed it, you would have a group project, you would have some kind of agile project rhythm going. Okay, but it's okay. It's not so bad, because you presumably in your project class you will work in an agile kind of environment anyway. Okay, I don't know if you actually have that agile manifest or agile protocol being followed or being taught to you, but it would have that kind of feel already. So, you know, with this being me just talking to my computer with some picture of the students staring back at me, and doing this remote, and everybody doing an individual project, it's not really something that was achievable. Okay, so this objective 4, I think we didn't really accomplish. That's all right. Okay, but overall, I have to say, you know, we kind of covered the items. Now the items again are not hard and fast, and so we covered quite a few things. And again, I tend to go over the thinking behind what's behind all this. And as you know, everything we've been doing just centers around the idea that we have a big set of data. Okay, maybe not big data in the formal sense of the word, but you want to understand it, you want to make use of it, so you visualize it. Okay, and you draw on your basic understanding of probability, statistics, linear algebra, calculus, to build on some kind of analytics. And the main types of analytics that we cover in this class would fall under unsupervised and supervised learning. Okay, so we spend a lot of time on that. So again, unsupervised learning would be things like akin to what babies do. You know, just make auto association between items. Okay, items that come together. Okay, you kind of put them together. Okay, so this covers everything from frequent item set. This is the old school, old-fashioned data mining, right? Frequent basket. People who go to grocery shopping, how often do they buy milk and eggs together and so forth? And if they bought milk and eggs, are they likely to also be looking for kitchen towels or whatever? Okay, so those are very old school, low tech, but computationally could be it's not something you can do by hand. You need a computer to do. Then of course you go to like things like cluster analysis, and these are very important because what you want to do is identify how data sort of like fall into natural cluster, right? And then we start to go to supervised learning, and this is where you actually have an XY kind of thing, right? Given X, can I say anything about Y? Can I predict Y, okay, as a value? Or can I identify, in which case Y is a label, okay? This is a picture, it's a cat, that sort of thing, okay? So, so we went over a few of those. We did a little bit more on unsupervised learning in terms of dimensionality reduction. This is where the idea is that you have data that have high dimension, 30, 40, 50 variables, right? But in a way, you can say that this clustering analysis, this kind of similarity, you can say that, yeah, 2 points are similar in 40 dimensions. But I kind of like to visualize that a little bit. So is there any way I can reduce 40 dimension into 2 dimension? Then I can say, oh, these 2 points are close together, okay? Now, dimensionality reduction is not just for visualization. It also has many other uses that you presumably will go into if you go to a machine learning class. It's very critical. So all kinds of tools there, right? And then we start having a project. We talk a little about how would you have this kind of project pipeline from the beginning to the end, right? And last week we talked about things like data validation, pre-processing, and post-analysis. These are sort of like, well, it's not just from A to B. It's not from data to machine learning model and results, right? That would be easy. That would be very nice. Sometimes that is nice if you have that, because if you're working with the Kaggle data, for example, it comes already clean for you. So you have to do nothing, just kind of feed it to your model. But in real life, chances are you probably have to do a lot of cleaning. And not only do you have cleaning, you might do some kind of pre-processing, some kind of stuff. And in terms of performance validation, you have to make sure that you're testing in the sample data and so. So all these skill sets are really, it's pretty much what a professional data scientist would have to cover, okay? But a lot in detail, more details than you, certainly. But this is sort of like, again, the objective is to put you in the mind, okay, in the mindset or in the experience of professional data scientists, okay? But again, not with the level of details and mission criticality that a professional data scientist would face, okay? Because that's their career. Okay, now, so today we wrapping up. So I need to do a few things. I need to do a few things. Okay, I have one more thing to cover. Okay, I have more sort of like area to cover, and this you can say that it's a little bit of a bonus in a sense that it doesn't cover 80% of the application. So let's say you're a professional data scientist working for online retailer or something like that. What we are talking about today might, okay, in some specialized use case be everything, but in terms of overall space of application, it may occupy maybe 20% of the jobs, okay, and maybe 10% of the jobs. And chances are they're not going to be hiring you to do that anyway. They're going to be hiring somebody with a Ph.D. or somebody with a lot more machine learning know-how. But it's good to understand where this is heading. So I have that's what I have to cover. I also have to cover a little bit about what are we going to do over the next 3 weeks actually, including the exam. So I'll talk a little bit about the exam, I'll talk a little bit about the presentation. Okay. Now, I think I made the, let's go to our little side note. Okay, let's go to a little side note. Okay. And let's see what we've got there. Okay. So these are things I want to talk about, but okay, first of all, in terms of your project presentation, okay, this is how we're going to do it, right? We're going to randomize order, okay? And so next week, everybody will be ready, okay? So at 1 o'clock, Peanut, your TA will say who's up, okay? And also who's next. So he'll just give 2 names, okay? The first person who's up maybe has 5 minutes to, whatever, 2-3 minutes to get prepared. And the second person, you know who's next, right? So when the next person comes in, the third person will be announced and so forth. So it's randomized order, and then you can prepare. So this hopefully will expedient the process a little bit, okay? Now, so randomized order. So some of you will present before others. Is it a disadvantage to be going first? Actually not. Actually not. Because your main deliverable is your project report, right? So actually, if you present the first week, you have my comments, you have your peers' comment, so you can actually have a week ahead to prepare your project, right? So so if you present first, yeah, you may be not as prepared in terms of the presentation itself as somebody in the second week, but you will also have an extra week of feedback to work on your project report. Okay, so it's sort of like, I think it's fair, okay, and it's all randomized anyway. So, okay, now in terms of presentation, what I'm going to do is I'm actually going to have you score your peer as well. Okay, so in other words, just like I have a scoring sheet. Okay, scoring sheet. Okay, I think 4 or 5 areas. If I remember, something like originality, execution, yeah, and sort of like insight or whatever. Yeah, I think I have quite a few things for quality or something like that. Okay, so this will be my score sheet. The same score sheet will be distributed to you guys, so you actually will be rating your peers. Okay, now you can't give them all 5 because you have a budget. Like, you know, you have a budget of stars. You can't give stars to everybody. Okay, something like that. So scoring sheet for scoring your peers. Okay, and this will be handed as an assignment. Okay, as well. Okay, and then your project report, of course. Now, I mentioned already, right? Your project is going to have a video. I've decided the easiest thing, and to save memory as well, I don't want you to send the video. You just kind of upload to YouTube, okay? And the title should be something like Big Data Analytics Project. Okay, so everybody will have the same title, right? So worst come to worst, I can actually search this if I can't find it. So you just upload to YouTube, right? Presumably everybody has a Gmail account, and then send the link, not the video. Okay, not the video because 40 students, don't forget, not the video. Right? So this would be sent to me, let's say, Monday. What's today? Today is what, the 9th, right? So Monday is the 15th, right? 8 a.m. Now, this is the videos that you will be using as part of your presentation. Okay, but you are more than welcome. This is very important. You're more than welcome to revise and resend a different version. Okay, So basically what you do is you just go to the YouTube thing and you just hide the old one and publish a win one and then send us the notification that you have updated. It's okay. So we'll know that you have an updated video. But just use the same thing. You don't have to say version 1, 2, 3. That would be too silly. Okay. So basically, this is the final version you send. So okay, Monday. But it always allow updating. Okay. That's fine. So that's the video. Now, here's the thing. In terms of presentation, okay, presentation is not the written report, right? Not the written report, the actual presentation. Again, okay, you have the video, okay? We may decide that, you know, the video looks interesting on its own, we'll watch the whole thing, or I may just, you know, interrupt the video and just ask you the direct question. But anyway, what you have to prepare, okay, you have to prepare slides, okay, i.e. PowerPoint. Okay? Now, I'll talk about content a little bit, right? In terms of PowerPoint, this is the usual class, okay, class reference to the mind map, okay, as to where you are, okay. In other words, where's that mind map? Let's go to this. So this is, oops, sorry. Oh. Why is that not coming up? Okay. Oh, it's here. Sorry. Okay. So in other words, this looks big, right? It's got 507 nodes. But basically, your problem, your data, you just trace out. Okay. So what I would do in the video, as well as in the video, I would just shrink everything and just unblock individual block as you go along. Say, this is my data, okay, in terms of my data, blah, 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 okay. So sort of like identify where you are, okay. And likewise, in terms of techniques, you come over here on the left-hand side, and this is the techniques of, are you using supervised learning? Okay, are you using unsupervised learning? Are you using decision tree type thing? So you just be saying, okay, for this project, we're using probabilistic learning. Okay, we're using supervised, and then you go to this one. Supervised has many ways. I go to decision tree based, and I use random forest or decision tree, something like that. So kind of like trace it. Okay, so basically, so you have to remember where you are in this schematics. And that's what you have to do. Okay. Now, so I sent you this already. Okay, I sent you this already, and okay. So that's what I want. I want you to have this as to where you are. But the main thing is the PowerPoint. Okay, the main thing. PowerPoint is very important, and I'll tell you why. PowerPoint presentation skill is very important. Yeah, it's very important. Now, you may wonder, if I think PowerPoint presentation skill is very important, how come I don't use it in this class? Okay. Well, you have to understand what PowerPoint is good for and what it's not good for. Okay. You know why? In my professional life, I must have written produce like thousands and definitely over 1,000 pages of PowerPoint. So for my professional work, PowerPoint is almost like a main method of communication, okay? Main method of communication. So you would think that PowerPoint is a universal method of communication. Wrong. I don't want to, okay? I prefer not to, and occasionally I have to, but I don't use it as a teaching tool. I don't use PowerPoint as a teaching tool. And I'll tell you why. The reason PowerPoint is good, and this is a secret that most people don't understand. Do you know why PowerPoint is good in business? Do you know why? Anybody? Just have a shot. Why do you think that I would use, hundreds and thousands of PowerPoint in my professional setting, but I don't use it for teaching, and I still ask you to do it? Why do you think PowerPoint is useful, is good? What is the best thing about PowerPoint? You know what it is? Anybody? No guess? Okay. If you
because it's like standard. Is it because everyone uses it?
Okay, that's good. Standard format. It's familiar. It's comfortable. Having said that, to be honest, this is not true. It's true now. It's not true before. Okay, it did not used to be like this. Okay, PowerPoint used to be just used within the business context. You would never see it in classroom. Nowadays, you see it a lot in classroom, because I think sometimes, I can see why it's more convenient for teacher to have like a prepared set of slides, and just for this class, you just turn it on and just talk it. What we call talk the slides. So it's a very easy way of teaching, right? You just have a set of slides, you go to the class, you turn it on, and then you talk the slides. And sometimes, to make life easier for students, you even print it out for students as handout. Okay, so it's very ubiquitous in that sense. Yeah, that is a good point. But that's not the secret of why PowerPoint is useful. PowerPoint is useful for the presenter, because the presenter, can control the narrative. Okay, think of it this way. Have you ever watched a really difficult press conference where somebody comes in and the news reporter asks a lot of questions and you have to answer that? Press conference is really difficult because you cannot control the narrative. The journalist asks you whatever question they want to ask. You may have an idea of what you want to say, but at the end of the day, you have to answer the question. Okay. Now, a lot of press officers just kind of avoid it. So they're like, yes, that's important, but let's talk about this. The reason PowerPoint is very useful is it controls the narrative. It allows me to say, in the space of half an hour, I'm going to pitch an idea, and this idea is linearized, because the slide 1 follows by slide 2, 3, 4, 5, 6, 7, 8. It basically forces the audience to follow the same path that I am dictating. So I'm dictating the narrative. Okay, that's why it's used for sales presentation, because the sales presentation, the narrative has to lead to conversion, lead to sales. Okay, so it doesn't matter what I talked about. Page 1 immediately leads to page 2, immediately leads to page 3, 4, 5, 6, and by page 8 or page 9, I'm starting to make the sales. Okay, so PowerPoint is something you have to master, because when you pitch the project, you want to control the narrative. You want to control the narrative. You want to say, oh, this is a problem, right? But before people start thinking, well, that's not really the problem, you already dictated this is the problem, right? And then on page 2, you already dictate these are 5 possible solutions, right? You don't allow the audience to think, well, what, you're not saying, oh, this is the problem. what's the solution? What solution can there be? You actually go to page 2. Page 2 say, for this problem, there are 5 possible solutions. And then you go to the next page, you say, the first 4 solutions, which is offered by the competitor, are no good. The 5th solution is the best, and we offer that product. So PowerPoint is a very mind control kind of thing, right? You are forced to go through the linear sequence of ideas that I already prepared for you. Okay? Now I'm not trying to get you to be cynical about this, but that is the objective of a pitch. Okay? So you narrow down the space of problem into the space of the solution, into the space of, oh, at the end of the day, only one person offer you the perfect solution, and that's my company, and that's my product. Okay? The audience cannot wander off because it's 1, 2, 3, it's one slide after the next. So even though reality is a tree, right? You can fork anytime. In PowerPoint, it's actually a guided tour. Okay? It is basically a guided tour. Now, guided tour can be very useful. I don't know if you'd like to go to museums. When I go to museums in a foreign country, okay, I don't have a lot of time. I would take the guided tour because the museum curator already knows what's the highlight and takes you through that. Okay, so you walk, you follow. So even though it's like a big space of museum, I walk in a line that's determined, predetermined. That's what a PowerPoint is. It's a guided tour. Now, if I have more time, and a lot of time, I spend a lot of time in the art museum, I don't take guided tour. I wander on my own. Okay, so to me, a class teaching should be not a guided tour. That's why I don't use PowerPoint. I may have to. I remember, now I've been teaching analytics long before you were born. I use PowerPoint to teach MBAs, okay? Because when I was, I've been teaching since I was a student. When I was a master student, I would tutor undergraduate. When I was a Ph.D. student at Imperial College, I would teach executive MBAs at Imperial College on quants. I would also teach at London School of Economics. But for executive MBAs, I would tend to use PowerPoint. And again, it's very easy because if I don't use the PowerPoint, the discussion can diverge really quick because MBA people sometimes they just want to say, oh, what about my company? My company does this. And I really don't care about anybody else. I just want to focus on logistics because I own a logistic company. I don't care about anybody else. I own a marketing. I just want to ask about marketing. So I really can't control the narrative. So I just make a PowerPoint and everybody, I don't care what company you work for or what company you own, you follow my PowerPoint, boom, 3 hours. You don't have degree of freedom. So it's a guided tour. I do that. Anyway, so that's kind of like a sidetrack. So teaching nowadays, you might see PowerPoint and it's a little bit convenient for the reason you mentioned. It's convenience, ubiquitous, and sometimes you can use that as handout for students. But I really think that teaching without PowerPoint is a lost art. It really is a lost art. When I was an undergraduate, my professor would just walk in. Literally, he would just walk in. He would walk in holding one book, okay? Not because he doesn't know the subject, but because he wrote the book and he kind of wants to show off a little bit, okay? So he carries the book that he wrote. Anyway, I'm just being funny. Anyway, so the teacher would actually, for 3 hours, teach everything that is relevant from his head, okay? So it forces the professor to really know his stuff. He can't just turn on the slides and talk the presentation. That's not option. That's not an option. For 3 hours, he used his chalk. Back then, they used chalkboard, and he has to teach the whole thing from his head. And that forces the teacher to have, basically, he has to be really solid with the knowledge. He can't be really imprecise because he doesn't have any kind of slide deck to follow on. And conversely, and this is more important, to me, this is more important, it forces students to organize the knowledge. Because when you see the PowerPoint, it's already in bullet form. Okay? Not only do you not have the degree of freedom to control the narrative, you already see the bullets. Okay? It's already organized for you. When you learn from, when I was a student, I learned from, teacher or professor that use chalkboard and write the whole thing. I have to create the structure. Okay, so it forces both the teacher to be really knowledgeable, and it also forces students to really pay attention. Because you can't say, hey, I have a handout, I'll just go back and look at the handout. You can't do that. You can't do that. It forces students to have a very, very concentrated mindset. Okay. And I think now, of course, I can't force every class to do that. I can only control my own class, so that's a style like this. But anyway, you are not trying to teach anyone. You are trying to pitch your project. So the advantage is to use PowerPoint. Because you want to control, you don't want people to wander off, right? If you're going to present, say, a prediction model, and there's actually a whole bunch better algorithm out there, you don't want people to start thinking about that. You want to say, well, for this problem, it's actually good to use this technique. Why? Because it's the technique that you use, right? So you control, hopefully, now, certainly I would not fall for it. Okay, I will not fall for it because if you choose a silly method when smart methods are available, it doesn't matter if it's in the next slide, I would ask you. Okay, but when you go to clients, a lot of time they want. Okay, so that's a little bit of a sneaky secret. So PowerPoint is useful for the presenter. It makes life easier for the presenter. Okay, so you have to do that. So the idea is, again, every decision, every talking point can diverge 1,000 ways. You choose the way that relates back to your project. It's as if for this problem, there's only one solution, and that's yours. Okay? Again, like going to the museum, you can go to any room in any order, but the best way to experience the museum is to follow a guided tour. Okay, and that's what, think of PowerPoint as a guided tour. Now, I'm not going to teach you PowerPoint techniques. Okay, I've used that since I was, I think I was probably about maybe a little bit older than you. I had to make a kind of professional looking presentation. But basically, those are the techniques you will have to master. I think Basai has a presentation coaching. I'm not sure they have a proper presentation communication course, but do that. Okay. Again, understand that in that class you would learn how to formulate ideas. You learn techniques like, don't put too many ideas if you don't want to confuse them. You want that sort of thing. There's different philosophy. There's some philosophy, but some thought, some school of thought that say PowerPoint, each page should have just 3 lines. If you have more than 3 lines, it's a bad PowerPoint. Okay, some people don't say that way, so different techniques. Anyway, long story short, you have to make a PowerPoint. Okay, because that's the best way to control your presentation. It's called presentation day. You're not teaching me. You're not trying to encourage me to think. You're not trying to get me to have a encompassing thought about the subject. You're trying to pick something. So it's sort of like in 10 slides, it should lead to motivation, to your conclusion, to why I think, oh, you did a great job. Okay. Parenthetically, not only did you do a good job, there's no other way. This is the right way to do it because A, B, C, D, slide 1, slide 2, slide 3, slide 4. By the time you get to slide 5, the audience shouldn't think about any alternative method, right? So it's a little bit manipulative if it sounds like it, but use it in good spirit. You're not trying to fool anyone, okay? And in fact, one of the objectives of Basai is to make you an educated consumer, so that when you actually become CEO or middle manager or whatever, and somebody is trying to pitch you with a very nice PowerPoint, you would be able to spot silly ideas that are dressed up to look nice. Okay, so I want you to be educated consumer of presentation, but now you're trying to be the seller of presentation. So that's what your PowerPoint. So you have to make you definitely have to make a very PowerPoint. Okay, it's control linearized narrative. Allows you to control, i.e. linearize. The narrative. Now, if one day you become a professional speaker, hopefully you have something more interactive, more exciting than just slide deck, okay? And so, second, allows you to be lazy, just off slide. In other words, you prepare one slide and you use it 10,000 times. You don't have to think about it, okay? It's not fresh. So you can do that. But more importantly, so this is sort of like a good reason, and this could be good or bad. Again, you can use it to good or to focus the attention, but you can also use it to mislead. Okay, so I want you to focus on this. Okay, so this is very important. Now, so you will have to have that, and so you have to again prepare all this, and what else did I talk about? The scoring. Yeah, scoring. Let's go there. Okay, finally for the exam, same deal. Yeah, don't tell you this test that you learn concept. Same deal. So, okay, so with that out of the way, I wanted to just sort of like spend half an hour, but maybe spend too much time. So now let's go to this week's lecture. So we start the lecture today. Okay. Let me take a break. Yes. By the way, this is just my comment. Okay, this is my side comment because I wish you success. When I was young, when I was a kid, I went to Satijula demonstration school. Back then, the quality that was lacking in, say, young children was the ability to express themselves. You know, the ability to just go in front of the class and talk and stuff like that. So whenever I went somewhere, I said, "Oh, I went to Satijula demonstration school." They say, "Oh, good, teach you to express yourself." So that's a skill that's very hard to find. Nowadays, the opposite is true. Nowadays, everybody's got a TikTok channel. So self-expression is not a rare commodity anymore. Okay, the ability, the willingness to share every tiny aspect of your life and express your thoughts and emotion, that's not a rare commodity. Rare commodity going forward is the ability to self-reflect and concentrate. Okay, so if you can self-reflect and you can concentrate, you know, like sit through 3 hours lecture and not have any cheat sheet to fall back on, that's a skill you should develop. Okay, now you don't have to develop from my course, you can develop from other things as well. You know, when you go watch a movie, watch a long movie. When you go to concert, go to classical concert or Thai classical concert. You know, a classical concert, the whole symphony has 4 movements. The whole thing is 40 minutes, not 3 minutes. Okay, so try to do that. Try to have this kind of long endurance, mental endurance. I think that's the rare commodity you should develop. Okay, that's your subject. Okay, so here's the deal. This is what I thought would be a good way of thinking about today's subject. So basically, right? We've done all this. Oops, let me turn this off. Okay, we spend a lot of this. Okay, spend a lot of this. Okay. So beyond decision tree, beyond K-means, okay, decision tree, multi-layer perceptron. What are the cutting-edge technology? Now, correspondingly, they're existing as well. If you think about it, they kind of mirror one another. K-means, decision trees, or and whatever else, right? Random forest, all this kind of thing. Multi-layer perceptron. These things are very good for tabular data. So all you have been doing, and will professionally looking 80% of the time is like fancy regression or fancy, let's say fancy stats, right? So you do statistics, you do distribution, well, you do K-means, you do unsupervised clustering, right? You do regression. Y is beta x1 plus b2 x2, right? So instead of doing this, you have y is equal to multi-layer perceptron x. Okay, but at the end of the day, you're just doing fancy stats on tabular kind of data. Okay, so today, so let's say you've been shown, and it's about kind of like new stat, or something like non-linear stat. Yeah? Sometimes when I was a PhD student in London, there was what's called nuclear winter, which means not nuclear winter, AI winter, a mini AI winter. People didn't want to use AI, so a very clever professor at London Business School used to say that he's not doing neural network research, he's doing non-linear regression. Okay, so he's doing something like non-linear regression. Okay, so he wouldn't say that he's doing neural network research, he's doing non-linear regression. Okay, and he could sell project to banks and stuff. So, but it's true. It's not much different from that. So, how can we go beyond this? Okay, what do I mean by beyond? How do I go beyond it? So, you mean something else besides supervised and unsupervised? Okay. Well, you have reinforcement learning, but I already told you that that's more like a robotic. Well, the idea is actually yes. Okay, but I'm not gonna say that yet. I'm going to say that what I want to do is actually I want to learn to create model around not tabular / numerical. Not tabular. Okay, so this is really the i.e. the B variety view of big data. Okay, remember we did that in the very beginning. I think it was class 1 that I was talking about data, and I was saying data itself, tabular, and here, this here. So most of your projects are kind of like going here, and in fact, I would say all of your projects are here. Okay, except the license reader guy. the auto license, and I think there's one text guy. I think there are 3 projects that doesn't go this way. Tabular numerical. So it's the V in big data. Okay. Now, the first thing that, let's say, after the 80%, I would say that another 10 to 15%, let's say 10%, involve text. So instead of tabular numerical data, it would be text data. Hence, natural language processing. Okay. Hence, natural language processing. Okay, this is NLP. Now, I'm not teaching you that today. Okay, I'm not teaching because it's big, because it has many. But I'll talk. I'll give you 15 minutes of it. Okay. So, what are other things? Okay. So today we talk about other things, and I'm going to put them under 4 ideas: LSTM, CNN, NLP, and CNN. Okay, so those are the 4 things that are beyond everything else we did cover. Now, if you take proper machine learning class, you will go deep into all of this. Okay, so let's talk one at a time. Okay, so the first thing is LSTM. What does LSTM stand for? LSTM is an acronym. It's a shorten. Long, short-term memory. Okay, it stands for long, short-term memory. Now, here's the funny thing. So is it long or short? It's actually a short-term memory, but it's longer than very short. So you have to know, well, what is really short-term memory? What's really short memory? So you have to ask. Then, so that means there's such a thing as short-term memory model. Yes. Okay, and that's called recurrent neural network. Now, let me put the word classical. So what does a recurrent neural network, okay, look like? Well, you guys remember multi-layer perceptron, right? Okay, so multi-layer perceptron. So first think NLP when input has time sequence and ordering, i.e. financial time series. Okay, so in other words, if let's look at some picture. Let's find some picture. Multi-layer perceptron. Okay. Okay, let's look at some picture. Oops. Let's find that picture. Let's find some picture. Okay, there it is. Okay, I'm just gonna blow this one out. Okay. Come on. Okay, how about this one? Okay, so where's a nice one? Okay, let's go to this one. I don't know why it doesn't. Hold on. Okay, how about this one? Sorry about it. Okay, how about this one? Okay. Now, notice there's only one Y. I'm really frustrated. Okay. There's only. How do I make this? Yeah. Okay. This is the best picture. I'm gonna blow this up. I don't know if you can see it. Okay. So this is an output. This is y. Y is a function of x1, x2, x3, x4, right? x1, x3, for example, is this person going to buy something? X1 is the income, x2 is the wealth, x3 is debt, x4 is, so x1, 2, 3, 4 is characteristic. So you feed one sample, that's one person, right? That's one person. Then the other person comes in, this one is female, this one has this much money, has this many cars, whatever, and then predicts the sale. The third person is a male, has this much money, has 5 cars, blah, 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 is he gonna buy? So each sample represents different client, different line on the tabular data, okay? But what if I'm predicting something that has a time series? For example, this is an economy, GDP of Thailand, given unemployment rate, interest rate, capital utilization rate, and import demand. And one data set is 1 quarter. So the next data is not a different person, it's still Thailand, but different time period. Okay, so the next quarter, again, capacity utilization, interest rate, whatever, okay, and then predict the GDP. So that would be like the time series, right? So this kind of order. Now, if you think of time series, if you think of modeling different kinds, it doesn't matter which order you add, right? You just add this guy first, and then the second guy, and the third guy. But with time series, there's a sequence, there's an ordering. So what you want to do is maybe you put in the present day, but you also want the previous period, okay? So you don't want just the present capitalization, interest rate, whatever of this period. You want the previous one as well. How do you do that? Well, the obvious way is to just say, have another bank of this along the side, right? Just make it bigger. Well, that's not really practical. What is practical is to do this. Use the data from the previous period, feed it, but then once you get to here, have a loop that feed the value back, feedback. So there would be the loop called recurrent neural network. Okay, that's it. Okay, the difference is between here and here. This, you just keep feeding the present period. This, you keep feeding the present period, but the past period information comes back. Past period comes back. This is called memory. Okay, memory. But this memory is very short because it's only one period to the next. Okay, so if you want to model something that has a sequence, okay, financial time series is a sequence, economic data is a sequence, sentence is also a sequence, right? Because I say, I play with dog. It's different from dog plays with I, or I dog play with. There's a sequence. So you put in I, then you put play, then you put with, then you put dog. So you want to keep some kind of information. So I play makes sense. So I does not make sense. So you don't want to use the previous value, something like that. So there's some kind of like a memory retention. I just said I just said play, I just said with. So the next word cannot be I, because I can't play with myself. I just play with my dog, right? I can't play with I can't play with airplane. I have to play with something that I can play with, right? So I play with, I also cannot say I play, or I play whatever, human, okay? It has to be a game or something. So it has to have this kind of sequence. So this kind of memory, okay, this kind of memory is called recurrent neural network. This is called recurrent neural network. Unfortunately, classical recurrent network has short-term memory. Yeah? So this long short-term memory means it keeps memory a little bit longer. It keeps the memory a little bit longer. So you will see this now. Pictorially, I'm just going to give you a very quick explanation. Okay? And this is the intuition of, so like looking under the hood again, I'm giving you the concept. Normally you have input and you have output. Okay? Now, if you have this kind of looping, it's the same thing as I can draw it this way. See that? So input, output, input, looping, output is the same thing as this. So maybe this is the picture I should show. Okay, take me a minute, just a second. Okay, yeah, this is a good picture to have. Oops. Okay, I'm accepting the cookies. What? Okay, fine. Okay, so input, output, but this input comes back for the next time. So it's going to look like this. So the neural network, even though there's only one neural network like this, they write it in snapshot. Okay, so this is input 1. Input 2 has a little bit of input 1 back to it. Input 3, sorry, input is up from the top. Input 1, input 2 has a little bit of back input to it, and then output. Input 3 has a little bit of back input to it and output. So this is the short-term memory we're talking about. Well, this thing here, if you make it more elaborate, you get something that looks like this. Okay, so I'm just going to make this long story short. This is how you make the signal. The signal goes like this. Signal follow the blue sign here. Signal follow the blue sign here. Okay, this is kind of old memory, and this thing decide whether or not you can erase. This is called forget, old memory. This is to say whether or not the new thing should be remembered, and this is to say whether or not the output should be sent. So it's more complicated. Okay, so it looks a little bit like this. But instead of saying that, okay, the previous period have an output and then comes back, becomes an input, you have a different loop, a loop that says sometimes you don't want to remember the previous, sometimes you do, sometimes you want to add to the memory. So this is very complicated, and this is called long short-term memory model. Okay, so this is so the only thing that you have to understand is that in the so in that 20%, whenever you work with time series, or something with that is not order invariant. Okay, again, invariant means it doesn't matter. Order invariant, I kick dog. Okay, Jane kicks dog. Okay, dog bites Jane. Okay, and then Jane bites dog. Okay. Is this order invariant? No, it is definitely variant because it means totally different, right? Same thing. Okay. If we talk about price of so something that's worth 100 baht today, and then it's 120 baht today, and then 145 baht. It's not equal to 100, 145, and then 120, right? The price goes up. Oops. The price goes up. This one goes up a lot, and then it comes back down. Okay, let's make it a little bit more dramatic. Okay. Which one would you rather invest in? This or that, right? Okay. So if you have to buy hold for 2 periods, this one gives you 50% profit. This one, you get excited in the middle, but by the time you get to the end of the period, you have only 1% gain. Okay. So this is not nice. Okay. So it's not. So whenever you work with something like this, you need memory neural network, i.e. modern RNN, modern recurrent network. So nowadays I use recurrent network as a general term. Modern. Okay. So that is e.g. LSTM. Yeah? LSTM. Okay. Now you will see other things as well, GIU, some variation, but chances are you see this word. So LSM. Okay. So that's it. That's the first thing. Now, notice, and here's a very interesting thing. I can put this number, right? You can do that right now because you know how to deal with numerical data. How do you put in dog? And that brings me to the second thing, which is NLP. How do you put in dog? How do you input to a neural network? Okay. Well, you can do this, right? Recall, if you are doing dog classifier, okay, you can say dog in picture is equal to 1. Okay. And likewise, dog not in picture is equal to 0, right? We call binary classification. Right? You can do this, right? As an input. So you can have now as input. As an input, you can also have x dog equal to 1 if dog included, 0 otherwise. But, and here's a big but. Okay? As an output, it's just a tag. In fact, I can do this. Right? I can even do this. It's just a tag. It doesn't mean anything. It doesn't mean anything. It doesn't have any information because the information is in the input. The output is the conclusion. It's not the information, right? It tells you the answer. Okay? But as an input, you want to have some kind of information. So you can say, you can have X cat, X dog. Now, imagine how many vocabularies. Let's go to internet. How many words in English? How many words are there in English? How many? Come on. Okay, 200,000 words. So you actually have to have X1, X2, X 2000. That's really not practical. So you can have a dummy variable. This is called dummy variable. But not practical with real language. Okay? So what you have to do is represent all words, say in English, type as vector of different variables. Okay? For example, dog is equal to 1, 2, 3. Yeah, something like that. Okay? Now, if you do this, because the number, this is continuous number, right? This is continuous number. I can actually pack in 2,000 different words in just 4 numbers because this is infinite. In fact, I can put in just 1 word. Okay, I can just put in that 1 word. Dog is equal to this, but I'm going to put it as vector. Okay. Now, the reason, and this is where you have to pay attention. Pay attention. Remember that vectors can have what? Similarity. Right? Remember? Cluster analysis. Right? Right? So here's the thing. How about representing all words as vectors such that similar in meaning translate to similar in vector. Right? Okay, let me show you. Okay, so if I have, for example, dog, okay, and I can have cat. Okay, let's say cat. is equal to 1.25. Okay. And then something like rocket. Yeah, I'm just making all this. Okay. Do you agree that this makes sense? Okay. Do you agree that this makes sense? Because cats and dogs are kind of like animals, and they are also pets. But you know, a rocket isn't, or you know, yeah. But a rocket may be similar. Oops, sorry. Okay. So you can see that in this case, cats and dogs are similar in meaning. But once you translate cats and dogs into vector representation, you can also say these two are so similar, but not this. That's what you want to do. Okay? And this is done by what's called word to vec. Word to vec. Okay? So in NLP, the most important thing you will hear is this technique called word to vec. Everything is built from this concept. Okay? And that's, we talk about this and we can say something like, queen minus king. Okay? The minus queen, minus male plus female equal to queen. What I mean is that vector, so this is called vector of corresponding to vector cat, and rocket correspond to vector rocket. What this means when I say that king plus female minus male is equal to king, what I mean is that vector king minus vector male plus vector female is closest to vector queen. Now, here you would, so here there'd be different technique of how this is done, but that's the technique. Okay, so that's what I mean by beyond. Okay, so now when you deal with time series, you deal with that. When you deal with words, you have to deal with this sort of thing. Okay, so let me, I kind of save a video for this as well. So you can watch this later. Okay, so watch that video and word to vec. Let's do that as well. Okay, good. Okay, so this is just a so you can actually spend the whole semester on this. Now, once you have word into numbers form, you can do word prediction, right? For example, you can say I. So you can put I vector I, okay, into a LSTM, and then you go vector play, okay, vector I plus vector play vector with, oh no, better yet, dog bytes, okay, and to LSTM, and then they get output vector O as close to vector J. Okay, so this is how you do sentence prediction. Okay, this, by the way, is how autocorrect one is. You know how autocorrects are always done. But you can imagine that autocorrect is done a little bit like this. Okay, think of autocorrect. Okay, something like that. Vector dog bytes, or let's make it Bowen. I think Bowen's more likely. So think of autocorrect in terms of application. Autocorrect. What else? Say chatbot. Okay. So everything that you've been playing with in your phone is kind of based on this. Okay. So if you type in dog bytes, okay, the phone turns the word dog into vector dog, turns the word byte into vector byte, and feed it to LSTM model, and this thing output vector something that's closest to vector. Okay, so this is how LSTM then outputs something closest vector space to vector board. Okay, then okay, so print dog bytes computer input. And let's make it more formal. Yeah, then output something closest to. Sorry, okay. Yeah, that's it. That's it. That's so once again, you are not working with tabular data, you're working with text data, right? So this is going beyond the tabular data, going beyond. So one technology is LSTM, or I don't want to use I could say RNN. Yeah, because but I don't mean old-fashioned RNN. So emphasize modern. And this one is called gated recurrent unit model. This is our name of neural network. Gated recurrent unit. Okay. Right. So run in and then P, zoom in. That's it. So word to vec, got that. Okay. Now we have two more things to cover. Let's see if we can cover. Maybe we should stop the video. Maybe Nakap halfway. Can we stop the video?
Okay.